Okay, welcome Year 11 back to the next video. In this one I'm going to take you through simultaneous linear equations. So what this means is when we have two straight lines, so two linear graphs, and they meet at a particular point. Where they meet, that's called the point of intersection, and what we're going to do is work out or use the calculator to work out what that point of intersection is, so what that coordinate is. Now, first of all, there is a special case where two lines will not meet. Generally, all lines will meet, provided they aren't parallel lines, because parallel lines, we know, never ever meet. So if you add that to your notes there, unless the lines are parallel, two linear equations will always meet at a particular point. So this example here shows you a couple of lines. We've got y equals 2x plus 1, and we've got y equals negative x take 4. So the point of intersection is this point down here. It will have a coordinate. It will have a coordinate in the form x, comma, y, and our task is to work out what that coordinate is. So we can use the calculator for this. Using solving simultaneous equations algebraically is a little bit tricky. So lucky for us, you do have a calculator that can help you out with this particular part of the topic. So the calculator instructions are written there for you, but I'm going to do this one as well on the calculator. So we are going to do it for these the same two equations that I've given to you just up here. We're going to work out what the point of intersection is. So where do they meet? So our two equations are y equals 2x plus 1 and y equals negative x take 4. What you want is a calculator page open. And what we do is we press menu, we go 3 to algebra, then we go to number 7, solve system of equations, and just number 1 here, solve system of equations again. So it's menu 3, 7, 1. This option comes up, it says number of equations. We can solve it for 3, but most of the time in this topic you will just use two equations. 2 equations and 2 variables. You can change those letters there, the x and y, if you need to. So what we get is this nice template coming up, and in these 2 boxes, this is where we're going to insert the equations that we were given. So just as a reminder, they were y equals 2x plus 1 and y equals negative x take 4. So y equals 2x plus 1, y equals negative x take 4. Make sure I've done that correctly. Yep. Okay, so what we do next is we just have to press enter, and you'll see that the x and the y values come up, and these are written as a coordinate. So if I go back to this page down here, you'll see there's screenshots of what I've just done. But oops, going a little bit too far. There we go. Gone way too far actually. There we go. Express your answer as a coordinate. So we have our answer would be written like so. So again, this is the coordinate where the 2 lines are meeting. Let's have a look at an example. We've got a couple of lines here. There's the equation of our first one, 2x plus 3y equals 12, and the other one is y equals 4x take 10. Now, first of all, you notice that this one here is not in the form y equals mx plus c, so we can't just go ahead and put it in our calculator just yet. What we want to do is rearrange it first. And you'll notice that is what I've done here, 2x plus 3y equals 12, comma y into solve, so that it rearranges it to say y equals. What I can do is if you just scroll up, you'll see that it highlights that equation. And what I'm going to do is copy that now. So press Control and then C. Go to your graph page. Press Tab to enter a graph in. And we're going to paste that equation there. So Control V. It is a lot easier than writing it out in full. The only problem is we do need to remove this y equals, which is here. So I'm going to delete that. Once I've got my equation ready, I press enter, and there it is there. What I can do is use trace here to get my coordinates of the intercept. So you'll see y-intercept is 0, 4, and if I scroll down here to the x-axis, my x-intercept is 6, 0. So 0, 4, and 6, 0. Let's mark that on. There's 0, 4, and there's 6, 0. And to complete that, I need to rule a straight line that connects those 2 points. So you want to try and get this in the right spot. It's a little bit difficult on the computer. I'm just going to try it again. Down a little bit further. It's a little better. And what we need to do is label that. Now, I just label it with how it was originally given to me, which was 2x plus 3y equals 12. So that's my first line drawn. My second one, I'm going to add. So just press tab and you can add another one. And the other line is 4x minus 10. Oops, back to the calculator. So 4x minus 10 and press enter. You can see that the point of intersection is right there in the middle, but what we're going to do is draw it on our graph first. Now what we need to do is get the coordinates of the intercepts for this graph just so that we can plot it correctly. So menu, trace, graph trace. You'll notice that it's on the blue graph at the moment. If you just press down, the down arrow, you'll notice it takes you to the other graph. Then you can move sideways and you can get the intercept. So this intercept here is 2.5. So let's mark that on. The x-intercept, 2.5. So in here. And the y-intercept we can see is negative 10, but because I can see it from the equation obviously, but what you can also do is check it on here and have a look there, negative 10, exactly what we expect. Okay, so if I go to Adobe, negative 10, down there. All right, let's connect that with a straight line and label it. So this one's going to be a little bit tricky. No, it needs to come over a little bit. Okay, try and get it straight through the lines. You can see it's a little bit tricky for me using this technology. Okay, and label it. So this one is y equals 4x minus 10. So what we're trying to find is this point here. You can see the point of intersection. It's roughly, provided that my graphs are accurate, are roughly 3, 2. But what we're going to do is use solve on the calculator and work out exactly what this point of intersection is. So what we need to do is get these into our solve function on the calculator. So if I go to my calculator back here, menu, remember it's 3, 7, 1, and I just need to press OK. So my two equations, they were 2x plus 3y equals 12. So there's my first one. And the other one was y equals 4x minus 10, wasn't it? Yes, okay. Whoops. So if we go back to our calculator here and press enter, we can see that the coordinate of the intersection is given, and it's what we expected. Mine was a little bit rough because my graph wasn't perfect, but I've got an x value of 3 and a y value of 2. So let's write that as a coordinate. The coordinate of the point of intersection will be 3, 2. You can see it's roughly that on my graph. It's not perfect, but you can mark it in like so. What you can do as well is get a little bit of practice. There are 4 examples here for you to have a go putting into your calculator and determining the point of intersection. So remember, menu 3, 7, 1. So let's do this first one. 3x plus 4y equals negative 2. So menu 3, 7, 1. Press OK. 3x plus 4y equals negative 2. and y equals 3x plus 7. Press enter and we can see that the coordinate is -2, 1. Let's go to B. 2y minus 3x equals 4. And x plus y equals 7. Whoops. So down to here, x plus y equals 7. Press enter. You can see our coordinate is 2, 5. y plus 2x equals -4. y minus x equals -8. And press enter. 2, -2 for this one. And finally, 5x minus 2y equals 1. And 2x plus 3y equals -11. Just double check that. Yep. And finally press enter. Now, I've made a little mistake here. You'll see I've got 2 equal signs, so make sure you don't do that. Then press enter. -1, -3. And they are our points of intersections for those 4 pairs of simultaneous equations. Okay, here we have finally, to finish off, a worded application question. So you'll see how simultaneous equations actually relate to worded questions. So what we've got here is a telephone company that's offering 2 different packages for their customers. So this first one's got a $21 monthly service fee, and then each call is going to cost you 14 cents. The second package, it's got a cheaper service fee, so only $7, but the cost per call is actually double. It's 28 cents per call. So what we're going to do is write an equation to represent each of these packages in terms of the total cost for a particular number of calls that you make. So for package 1, I'm going to call it cost 1 or C1. Well, it's going to cost you $21 whether you make any calls at all. So 21 plus, let's add on the price per call, which is 0.14, and we need to multiply that by the number of calls. So for each call that you make, it's going to add on $0.14 or 14 cents. For the second package, so I'm going to call that C2, it's only a $7 monthly service fee. So only $7 to start off with, plus add on. Notice that everything in my equation is in dollars. I can't write 21 and then use 14 times n because it's not $14, it's 14 cents. So you need to convert, make sure all your units are the same. And there's my 2 equations. What I'm asked to do next is graph both of these on the same set of axes. So both graphs are going to be on one single set of axes, and you'll notice it says for n is between 0 and 200. So really all I need at this point is the positive part of the y-axis, because I'm not going to have a negative cost, and I just need my x values, or my n values in this case, to be between 0 and 200. Now I'm actually going to draw this on using a different program just to make it easier to draw. And I've set up a set of axes already for this. I just might need to move this down a little bit so you can see it. And there it is there. Okay, so what I need to do is, you'll see that I've marked on I've marked on from 10 to 70 and I've marked from 50 to 200, but first you'd probably want to put these into your calculator just so you can see. I'm going to get a new graph up. So if I go to Home, new graph here, I'm going to press Tab, and let's get these into the calculator. So the first one was 21 plus 0.14 by x. So I'm using y's and x's because that's what the calculator does. And when I press enter, you'll notice I can't see the graph, but that's only because my window isn't ideal. So I'm just going to zoom out a little bit. There's my equation there. I'm going to add the other one to it. So I'll press tab to do that. And my other equation was 7 plus 0.28 by x, and press enter, and you'll notice there's the other equation there. You'll also notice I can't see the intersections. I can't see where they meet. So I want to make sure I can see more of this window. I'm going to change the window settings. So if I go window settings here, and remember I want the n values between 0 and 200. So that's what I'm going to change this to. Between 0 and 200. Press OK. Again, I still don't have enough of it, so I need to change the window again. So at the moment, the maximum Y value is 33.27. I'm just going to increase it a lot just so I make sure I can see it. So the window settings, the Y maximum, I need to increase that so I can see. I'm going to bring it up to 100. And there we go. That's a lot better. So I can see between 0 and 200, there's my two graphs of the two packages that I'm looking at, and we can see the point of intersection is in there. What we want to do is graph these now. So the y-intercept, that part's easy because we can read that from the graph. When we want to graph between this here, between 0 and 200, basically what we want are the coordinates at this point. So that's the y-intercept. But we also want to know what is the coordinate at the end point. So what's the coordinate when n is equal to 200 for each of these graphs? So what I'm going to do is I can use graph trace for this as well. I'll just move these labels out of the way. They do get a bit messy. Go menu, trace, and graph trace. At the moment it's on the black equation you can see here, which was 21.0.14. That is the first package. Now if I just enter any number in at the moment, I'm going to type in 200 and press enter. It's going to give me the coordinate at that point, and have a look, it's at the bottom, 249. So I know that the first equation passes through that point. So 249, let's mark that on. 200 is here at 49. You'll notice that once you do graph your equation on your calculator, it gives you a better idea of what the scale should be. It helps you out with this vertical scale here. So my graph passes through that point there, and the y-intercept was 21, so that's down here. And to finish that graph off, I just need to connect with a straight line. I'll do it in a different color. So there it is there. I'll mark on this point here, which is 249, and this one here, which is 0.21. And there's my first equation graphed. You will need to label it as well. Oops, that doesn't look too neat. Yep, 0.14n. There we go. Second one now, if I go back to my calculator here, just press the down button, so this one here, the arrow, and it will take you to the next graph. And because I already had 200 written in there, it's automatically taken me to that point as well. And we can see that the other graph passes through the point 263. So I'm going to mark that on. I'm going to use a different color. So 263, that's up here. So try and use a ruler. It's about there. And the y-intercept, remember, was 7. So that's about here. connect those with a straight line. Label your two equations. So this one's 7 plus 0.28 n. This coordinate here, that was 263, and this coordinate down here is 0, 7. So you do need to make sure these endpoints are labelled and the two graphs are labelled as well. You can probably spread it out a little bit more. Mine's a little bit cramped up there. So we've graphed both equations from 0 to 200 for the n value. Let's have a look. How many calls would you need to make for the cost of these to be the same? So basically it's saying, what is that point of intersection? What is this point? What's the coordinate of that point in there? So how many calls? What's the n value at that point? What we can do is we can use our graphs, or we can use our equations that we've got here. What I'm going to do is, just like I did before, menu 371. This is a point where you could change this to, say, C and N, if you're using C and N in your equations. So if C is equal to 21 plus 0.14 by N, the other equation was C equals 7 plus 0.28 by n. Press enter and you'll notice that when C is 35, n is 100. So this means that when you make 100 calls, the C value, the cost, is the same for both packages. The cost is 35 for both packages when you make 100 calls. So what we can do is mark in that coordinate there. So what I'll do is say, okay, when n is equal to 100, so when number of calls is equal to 100, the cost of both packages is $35. And we should be able to see that on this as well. If you have a look here, if we do graph trace and we look at when n is 100, have a look, it's taken us right to that intersection point. 100 calls, cost is $35, and that is for both graphs. If I press the down arrow, notice it takes me to the black graph, and it's exactly the same coordinate at that point. Okay, final question now. It's saying, for what number of calls would package 1 be cheaper? So if I look at the graph again, package 1, now that was the one that was 21 plus 0.14, wasn't it? So package 1, if we look before the point of intersection, it has a higher cost. It has a higher cost because the graph is above it, because this is cost here on the vertical axis. So the higher the graph is, it means the higher the cost at that particular point. So therefore, between 0 and 100 calls, package 2 was actually cheaper. But after you make 100 calls, so more than 100 calls, you'll see that the black graph is actually underneath the pink one. That means that it's cheaper. It has a lower cost. So what I can say then is that package 1 is cheaper when more than 100 calls are made. Another way of writing that is n is greater than 100. So when n is greater than 100, when the number of calls is larger than 100, package 1 is actually going to be cheaper. So despite the fact that you're paying more at the beginning, you're paying $21 as opposed to $7 at the beginning, because you've got a cheaper rate per call, you do get to a point where it is cheaper. And that point is 100 calls, the point of intersection. So thank you very much for listening to this video. I'm sorry that it is a little bit long, but that takes you through simultaneous equations, the points of intersection, how we can use the calculator for that, and how it relates to worded questions as well.